Hi everyone, welcome to the Mathemagic channel. Today we look at how we can solve this fourth degree equation. Now, typically a quartic will have 4 solutions, but this one's a little bit different. Let's try it out. Okay, let's try it out. So as a disclaimer, I will say this is not the only way to solve this question. It might not even be the fastest way to solve this question, but it is definitely a way. And so it's interesting to explore different ways to solve different questions in mathematics. So here we go. Today we're going to approach this by moving the x to the power 4 to the left. I will say here that you can definitely do a binomial expansion and expand the bracket to the power 4. We can probably have a look at that at the end of today's video, but we're going to use this formula here, which is the difference of two squares. And so you realize that something to the power 4 is something squared squared, right? And so when you have the difference of two squares, like you see on the right hand side right here, a squared minus b squared, you can say that it's a minus b factor of a plus b. So if you consider that you have x minus 4 squared squared minus x squared squared, you could take the first term minus the second term and then the first term plus the second term and try and simplify it this way. And at least we know that that's a good way because we have formulas to solve quadratic equations, whereas we don't have a direct formula to solve a quartic equation. So this direction will lead us somewhere, which is something important when you strategize in mathematics. So doing this, we get x minus 4 squared minus the second term x squared. And for the second bracket, we get x minus 4 squared plus the second term x squared. So this is this whole a minus b factor of a plus b thing. Now, using a standard expansion for x minus 4 squared minus x squared, we expand the bracket. We use the a squared minus 2ab plus b squared formula, which gives us x squared minus 8x plus 16, to which we still have to subtract x squared. And so this is good because x squared minus x squared, that's going to be a linear factor. We're just going to be left with 8x minus 16 here, or negative 8x plus 16, which will be pretty easy to solve. For your second bracket, we have x squared minus 8x plus 16, and this time it's plus x squared. So x squared plus x squared is going to go together and give you 2x squared, and here we'll have a quadratic to solve. Again, we're pretty happy doing that. So simplifying those, we get negative 8x plus 16, factor of a quadratic, so it's like a linear equation, factor of a quadratic. So here we go. We factorize by negative 8 and we're left with x minus 2. Be careful because when you do minus 8 times minus 2, you get the positive 16. And for the second bracket here, we're going to factorize by 2, leaving x squared minus 4x plus 8. And so we can move the negative 8 and the 2 to the right-hand side, because if we say 0 divided by negative 8, we have 0. And if we go 0 divided by 2, we still have 0. And so that'll leave us with two good brackets, the x minus 2 factor of x squared minus 4x plus 8. That'll be nice and easy to solve. And so this is a good equation to work with, a little bit cleaner. And so in this section, x minus 2 factor of a quadratic, we have a linear and a quadratic. We need to realize that we have two things multiplied by each other. And so when we do that, when we have two things multiplied by each other, either the first term must be equal to 0 or the second term must be equal to 0, because the multiplication of those two terms is equal to 0. And so that means that either x minus 2 is going to be equal to 0, which is a very easy solve, or x squared minus 4x plus 8 is going to be equal to 0. So either or. So we can separate this equation into two cases. Now, x minus 2 being equal to 0, that's great. That means x is equal to 2, and we can check that by putting that back into the initial equation. Now, for the second term, we have a quadratic equation, x squared minus 4x plus 8, and this also should be equal to 0. Now, when you look at factorizing this and roots of this equation, which might multiply to positive 8 and add up to negative 4, well, there's no numbers which come to mind, so this equation is not easy to factorize. And so therefore, I would encourage you to use the quadratic formula when that's the case. I like to start with the discriminant, which is b squared minus 4ac, to see how many solutions we have. And so the a value is 1, the b value is negative 4, and the c value is 8. So we can start with b squared, which is going to be, so if we rewrite our quadratic without the brackets here, we'll have 4 squared, so b squared is negative 4. Negative 4 squared is going to be 16, same as 4 squared, so it doesn't really matter that it's negative. Minus 4 times 1 times 8, so 16 minus 32. And lo and behold, we get a negative value for delta, and delta is supposed to go under a square root in the quadratic formula. And so when you get a negative value for delta, that's the end. There are no solutions. We're done. However, that only applies to the real numbers. So in the real numbers, we have no solutions, and that's just the end of the question. However, we're trying to advance our mathematics a little bit, and this is going to lead us to a little bit of work with the complex numbers. And so we can change negative 16 to 16i squared, knowing that I squared is negative 1, so this has to do with complex numbers. If you're familiar with imaginary numbers, then this shouldn't be a problem. And therefore, we can say that the square root of delta is actually 4i. And so using that result, we can remember that we found a first solution in the real numbers, which was x equal 2. And we're going to look at the square root of delta being 4i and to apply the quadratic formula here. So let's look at our quadratic again. X squared minus 4x plus 8. Now the quadratic formula is minus b plus or minus the square root of delta over 2a. So here's the quadratic formula, and we probably will get two solutions in C, which is the complex numbers. So we don't call them x's, we call them z's in C. So we'll have 4 plus or minus 4i, so negative b plus or minus the square root of delta, which was 4i. So b is negative 4, so negative 4 is going to give you 4, and then plus or minus 4i divided by 2 times the a value, and the a value is in front of x squared, it's 1, so divided by just 2. And we can simplify 4 plus or minus 4i divided by 2. We can say it's just 2 plus or minus 2i. So this will be our result for z1 and z2 here. And therefore we have 3 solutions. We have one real solution, which is 2, and 2 imaginary solutions, which are 2 minus 2i and 2 plus 2i. We could have worked with the roots of unity. We could have worked with quadratic factorization right from the get-go, where we reduce x to the power 4 to x squared. There's a bunch of different ways we could have done this problem. We could have looked at graphing solutions. But the real question here is, why do we only have 3 solutions when it's a 4th degree equation? Typically a quartic will have 4 solutions, but we've only got 3 here. Well, one of the explanations is that the real root 2 is a repeated root and is a double root. Now you can find that by inspection if you graph this, this equation. Another explanation is that this is actually a cubic equation in disguise. And so if we look at the expansion of x minus 4 to the power 4 being equal to x4, so if we did a binomial expansion, and the binomial expansion here is quite easy, we can use Pascal's triangle with coefficients 1, 4, 6, 4, 1, using powers decreasing from x4 all the way to x to the power 0, and increasing powers of 4, so from negative 4 to the 0 all the way to 4 to the power 4. If you're not familiar with binomial expansion, go and have a look at it, but this is what it would look like. It'll be x4 plus 4x cubed times negative 4 plus 6x squared times negative 4 squared. So you see the powers of x are decreasing, x4, x3, x2, x1, x0. The powers of 4 are increasing, 4 squared, 4 cubed, and 4 to the power 4. You notice as well the coefficients of Pascal's triangle at the beginning, 1, 4, 6, 4, 1. So these are the components of this expansion. But more importantly, if you simplify it, you get x4 on the left and x4 on the right. And if you move the x4 from the right to the left, the x4s are going to cancel out, and you're left with a cubic equation. And a cubic equation will naturally have 3 solutions. And this is why we can say that this question is more likely a cubic problem than a quartic problem. Still, it's an interesting problem just because we get to solve a quadratic with complex solutions. I hope you enjoyed this video. Thank you so much for watching the Mathemagic channel, and keep practicing your mathematics. Being a nerd is totally cool. You will still have friends, and we shall see you on the next video. Thank you.